Computing actual areas from scale drawings. Students identify a scale factor by taking the new shape over the original shape. Given, which is R now instead of K. Given the scale drawing, students compute the area in the actual picture. So remember, area is length times width. So use the diagram below to find the scale factor and then the area of each figure. So we got to remember it's the new or the scale drawing over the original. So we have the old is the actual, the scale drawing is the new, and we did the scale over the new and the scale over the new. And in both cases, we got a scale factor of 2. The actual area, well, this one, 4 times 3. Oh, how'd that move? 4 times 3. So length times width is 4 times 3, which is 12 units squared. Units squared. And then the scale drawing is length times width, so it's 8 times 6, which is 48 units squared. Now the ratio of the scale drawing to the actual, so the scale drawing, so that's 48 area over 12 is 4. So how do I compare 2 to 4? And remember, we're talking about units squared. Well, how about if I square 2, and that'll give me 4. So again, new over the old, the new being the scale, the old being the actual picture. So the scale factor of those are 1/3, because 2 divided by 6 and 3 divided by 9. We cannot allow this to be 0.3 repeating, because when we use that, it won't work out right. So when you have this, actually I shouldn't put that not equal sign. It's 0.3 repeating. Don't use this. You have to use the fraction. So our scale factor is 1/3. The area of the actual is 54 because it's 9 times 6. The scale area is 2 times 3, which is 6. So now if I do the ratio of the scale drawing to the actual drawing, it's 6 over 54, which is 1/9. Well, if I take 1/3 squared, it'll be 1/3 times 1/3. We multiply straight across, so 3 times 3 is 9. So 1/3 squared is 1/9. The next one. The actual and the scale. So new over old. Oops. So if I take a look at our shapes here, if we take the scale as the new, so if I take this side, the 12 over the 9, I wind up with 1 1/3. Then if I do the 8 over the 6, I wind up with 1 1/3. So our scale factor is 1 1/3, or to work with it just a little bit easier, remember you multiply the denominator by the whole number and add the numerator, so that's 3 times 1 plus 1, which is 4. So 1 1/3 is also 4/3, and that's a little bit easier to work with. So the area of a triangle is 1/2 length times width. So the area of the triangle, 1/2 base times height, length times width. So it's 1/2 9 times 6. So 1/2 times 9 times 6 is 27, because a half of 6 is 3, so 3 times 9 is 27. Now the area of the scale drawing is 12 times 8 times 1/2. So we would have 6 times 8, because 1/2 of 12 is 6, times 8 is 48. So now if I do the ratio of the area of the scale drawing to the actual, it's going to be 48 over 27, which is 1 7/9. So if I take my 4/3 and square it, I wind up with 16/9. 4 times 4 is 16, 3 times 3 is 9, and that equals 1 7/9. So again, if I take the scale factor and square it, I find the ratio of the areas.